Today I'm going to answer a question from a student who goes by the name of Nova Storm. And the question on the video on What is Ground is, this is very counterintuitive. Why are you coming up with different values for V? Isn't voltage the same across all points in a parallel circuit? Well, I'm not sure about exactly which part of the video you're talking about. I suspect it's in the point where I'm talking about the ground and safety. But I think I know where your confusion is because it's very common. It used to confuse me. So let's take a look at a typical circuit and see where I think your problem is. Let's put a resistor here and a resistor here. Another resistor here. So we have a parallel circuit, right? Let's put 10 volts here because we can, and let's make each of these 20 ohms. And I'll make this 10 ohms. Now, the question is, how much current is flowing through that resistor? So let's calculate that out. It's very easy, just Ohm's law. If you know your voltage, you divide into it. So I have 20 ohms and 10 volts. So 20 goes into 10 0.5 times. So that's going to be 0.5 amps. Right? Wrong. And this is a very common mistake I used to make, and I think it's because when people are explaining these circuits, they tend to rush it, which is exactly what I just did. Remember, this is a parallel circuit over here, but it's a series circuit over here. We have to look at our parts of our circuit separately to see what they're doing. So if I block off this part of the circuit here, what do we have? Let's get that out of the way. So this is blocked off. We have one possible current path through some circuitry over here and back. And by definition, a series circuit is a circuit that has only one possible current path. So it comes out of the battery into the circuit and then back to the battery, one path. So it's a series circuit. But now if we block off this half of the circuit, what do we have? We have current coming in this way. Now it splits off two current paths and then they come back together. So that's a parallel circuit. So we have a combination of a series circuit and a parallel circuit. So before we start seeing what's going on over here, we have to see how this part of the circuit affects that. And so it's very easy to look, oh, 10 volts, 20 ohms, half of an amp. But we don't have 10 volts here. But wait a second, I thought you said a parallel circuit has the same voltage everywhere. Isn't that 10 volts, 10 volts, 10 volts? No. We start out with a series circuit and we have to deal with how a series circuit acts first. So let's simplify this and see what's happening. So what we're going to do is zoom out until these two resistors merge into one. So what would that total resistance be over here? Well, we have 20 ohms in parallel with 20 ohms. What about the 10 ohms? That's over there. That's in another part of the circuit. We're only looking at this part of the circuit where we have 20 ohms in parallel with 20 ohms. Well, we know if we have two equal resistors in parallel that the total resistance will be half of either one. So these two resistors together act like 10 ohms. So now let's zoom out until they merge into one resistor. And they are now acting like a 10 ohm resistor. So now we have a series circuit. Now this 10 ohm resistor is actually two 20 ohm resistors in parallel, but we're zoomed out, we can't see that. We just see them acting as one resistor. So now what's going on with the circuit? We're starting out with 10 volts. So let's put our black lead here, making that 0 volts. And then we're going to use our red lead and start measuring voltages. So we put our black lead here, our red lead there. We're going to measure plus 10 volts. What are we going to measure here? Well, we have two equal resistors in series. We know that the current is the same through both of them, but moreover, we know that the voltage is going to be equal because the resistors are equal. Now, in a series circuit, the voltages tend to be different, but since they're equal resistors, they're equal voltage. And Kirchhoff's voltage law says the voltage across this resistor and the voltage across that resistor must add up to the source voltage. So the voltage here and the voltage there must add up to 10, and they must be equal voltages. So we have, let's just draw that in green here, 5 volts, 5 volts. 5 volts plus 5 volts equals 10 volts. That all adds up and it works. So we start with 10 volts and then we have 5 volts. What's going to happen? We have conventional current flowing that direction, and we know the voltage is going to be higher where conventional current enters the resistance and lower where it exits. This is anchored at 10 volts. This must be lower by how much? 5 volts. So we start with 10, we lose 5, and we have plus 5 volts left over. So now we have 5 volts across this 10 ohm resistor. But remember, that's not a 10 ohm resistor, it's actually two 20 ohm resistors in parallel. So let's zoom back in so that we see those two resistors for what they are. They're actually 20 ohms and 20 ohms. Now if you want to know what the current is through this resistor, there's a number of ways we can look at it. We can calculate it with Ohm's law because we now have how much voltage across here? Is it 10 volts? No. We started with 10, but we must lose voltage if we have current going through a resistor. So if current is going through that resistor, we must have a voltage differential across it. Whenever we have current plus resistance, we will have voltage. The voltage must be higher here, lower there. So we start with here and we lose a certain amount of voltage. We lose 5, so we start with 10 and we have 5 left over, so we only have 5 volts at this point. So now 20 ohms and 5 volts. Now we're going to have 0.25 amps through there, not half an amp, but a quarter of an amp. So we have to be careful and look at all points of the circuit, zero in on the part that's important now and ignore all that's around it until we figure out what's going on in a particular place. So that's one way to calculate the current. The other way would just be to use Kirchhoff's current law and say, okay, I have a certain amount of current going this way. And what do we have? We have 5 volts across 10 ohms. So 10 goes into 5, 0.5 times. So that's going to be 0.5 amps here. That's going to split. Some of it's going to go that way. Some of it's going to go that way. They're equal resistors, so they will have equal current, and those two currents must add up to 0.5 amps. So Kirchhoff's current law says that the current in the different branches must add up to the total current. So our total current coming out is half of an amp. It splits equally. Why is it equal? Equal resistors, equal split. If they were not equal, the split would be unequal, but we're not going to worry about that now. There's plenty of videos and study material on parallel and series circuits, which I recommend you go to. They're linked below. So equal resistors means equal current, and they must add up to 0.5, so that's going to be 0.25 amps and 0.25 amps. So more than one way to skin that cat. So that's the mistake I think you may have made. So I think the problem you were having was probably in the part of the video about ground and safety, but it could have been somewhere else. But no matter where you were, go back to the video and look that over again and keep in mind what I told you here. Don't forget to look at the different parts of the circuit separately. Just because we have a parallel circuit here doesn't mean that the circuit in all places acts like a parallel circuit. So we do not have 10 volts, 10 volts, 10 volts. We start out with 10, we lose 5 volts in the series part of the circuit, leaving 5 volts left over in the parallel part of the circuit. So yes, we have 5 volts here and 5 volts there, but then we have this resistor separating us from the supply, and there's a 5 volt loss across there, leading to the circuit being the way we are. So just be careful and make sure that you isolate your parts of the circuit as you examine them so that you know what part is parallel, what part is series, and be able to work them together. So I recommend that you go to rsdacademy.net and study the series parallel and series parallel circuits and the series of videos on those subjects to make sure you thoroughly understand this. Then look at the video on what is ground again. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.